Good morning, everybody. Now that we've spent some time looking at basic integration and the fundamental theorem of calculus, part one, we need to talk about the different properties of definite integrals that we can use to find the integrand or the antiderivative. And these should look familiar to you in the sense of they're very similar properties that we discussed when we talked about derivatives. So the first property we're going to talk about is when we find the definite integral of f of x d of x from a to a. So our upper and our lower limit are the same. All right, which essentially, if we use the fundamental theorem of calculus, we mean f of a minus f of a, which we know would equal 0. All right, so if the upper and the lower limit are the same, the integral equals 0. All right, the second property states, given that c is a value found within a and b, all right, the definite integral from a to b of f of x d of x is going to equal to the definite integral of a to c plus the definite integral from c to b. And this will only be true if c lies between a and b. The third property states that if the definite integral from a to b of f of x d of x equals k, then when the upper and lower limit switch, the value of the integral switches in sign as well and becomes negative k. All right. Now, what you should have been noticing in all of the problems that we've done is that b would be the upper limit and a would be the lower limit, which means that b would be the larger value. Well, in the case that b is actually smaller than a, the definite integral is going to equal the negative value of b to a f of x d of x. Now, this is only true if our original upper limit is smaller than the lower limit given to us. Okay, next, if k is a constant, then the definite integral from a to b of k times f of x d of x is equal to k times the definite integral from a to b of f of x d of x. Okay, if we have a constant being multiplied by our function, we can move that constant out. All right, if we're adding or subtracting multiple functions when finding the integral, we can separate it by adding and subtracting the value of each individual integral. Okay? All right. So finally, the last two we're going to talk about is when we have an odd or an even function. If we have an even function, so our upper and lower limits are opposite in sign, so negative a to a, all right? And remember, when we talk about an even function, that means that we have y-axis symmetry, okay? We have y-axis symmetry, all right? The value of this integral will be 2 times the definite integral from 0 to a f of x d of x. Okay? It's going to be twice this area. Okay, twice this area. And that would make sense because it's completely symmetrical and that's what makes it even. All right? Now, given that our function is an odd function, and remember that means origin symmetry. The definite integral from negative a to a of f of x d of x equals 0. And let's talk about why that would be the case. And I'm sorry, I just realized I drew my image incorrectly. This is the area because it's the area between the curve and the axis. Well, as we remember, all right, in this case, the areas would be exactly the same numerical value, but the area underneath the axis would be negative, whereas the area above the axis would be positive, and therefore it would equal 0. So let's talk about how we could use these properties to help us evaluate some definite integrals. If the definite integral value from 0 to 3 of f of x d of x equals 6, and from 3 to 7 f of x d of x equals negative 8, determine the value of each of the following integrals using the properties that we just discussed. All right, so the first one I'm asking you is to find the definite integral from 3 to 0 of f of x d of x. All right, and what we should be noticing here is this is that property, all right, in which our b value is less than our a value. All right, which we should remember means we just took the negative. All right, we just took the negative when we flip it. So in this case, it would be negative 6, because we know, based off our information above, that the integral from 0 to 3 of f of x d of x equals 6. All right, if we look at the next one and we take the definite integral from 0 to 7 f of x d of x, well, based off of what we were given, this would equal the definite integral from 0 to 3 of f of x d of x plus the definite integral from 3 to 7 f of x d of x. That's how we would get from 0 to 7. So that would be 6 plus negative 8. So our answer would be negative 2. All right, I would now like you to do the next two on your own. All right. Now let's look at another one together. Finding the definite integral from 3 to 7 of 2 plus 3 times f of x d of x. All right, and just as a reminder, and I'll put this here, from 0 to 3, the definite integral equals 6. And from 3 to 7, definite integral equals negative 8. So we're definitely going to have to rewrite this as the definite integral from 3 to 7 of 2 plus the definite integral from 3 to 7 of 3 f of x d of x. All right, so we know that this becomes 2x from 7 to 3. We actually have to use the fundamental theorem of calculus, plus 3 times the definite integral from 3 to 7 f of x d of x. All right, so here we would be doing 2 times 7 minus 2 times 3 plus 3 times negative 8. All right, and this once again is the fundamental theorem of calculus, and this is just using our properties. All right, and we would get negative 16 as our answer. All right, I'd like you to do the next two on your own, okay, all based off of it being an even or an odd function. All right, now that we've used them algebraically, let's look at it if we are given a graph. All right, so for this one, picture to the right is the graph of the function f of x. What is the value of the definite integral from 0 to 3 of f of x d of x? So remember, the definition of the definite integral, all right, is the area underneath the curve in the x-axis. So in this case, they want this area. Now, we have no other values given to us. So the only way we know how to do this, all right, is by using geometric area formulas, where we have a quarter of a circle, a rectangle, and a triangle. All right, quarter of a circle, a rectangle, and a triangle. So if we did the quarter of a circle, all right, okay, which would be this first part, all right, we know the area of a circle is pi r squared, okay? So in this case, all right, in blue, our area would be 1/4 pi r squared. And by looking at it, our radius is 2. So the area of our quarter circle is pi. All right? The next part we would have to look at is our rectangle. Okay? The area of our rectangle here would be base times height, which in this case would be 2 times 1, which would equal 2. And the last part we would have to look at is our triangle here. All right? And we know the area of our triangle is 1/2 base times height. So 1/2 times 1 times 1 equals 1/2. So we would add all of these two together, and we would find that the value of our definite integral would be pi plus 2.5. And that would be the correct answer. Okay? So let's see what else could be asked of you from this graph. All right, so what's the value of the definite integral from 0 to 4 of f of x d of x? And what's the value of the definite integral from -3 to 3 of f of x d of x? Go ahead and remind yourselves of the properties to answer these two questions right now. All right, so the last thing we need to look at is answering some more challenging questions, such as this. If f of 0 equals 5, what is the value of f of 3, where f is the antiderivative of f of x? Okay, so the key thing here is that we're given these x values of 0 and 3, and we know that f is the antiderivative of f of x. Okay, so essentially f is going to equal to the antiderivative of f of x. All right, and we know the upper and the lower limits. They're telling us it's 0 and 3. Okay, so I want us to think about that. All right, we know that this, based off of the rule of the fundamental theorem of calculus, is going to equal f of 3 minus f of 0. Okay? Now, what's great about this, all right, in essence, and let me rewrite this over here. So this is going to be f of 3 minus f of 0. We already found what this value equals. This value equals pi plus 2.5. And we know f of 0 equals 5. That's what's given to us. So now we can solve for f of 3. And f of 3 will equal pi plus 7.5. All right? So now what I would like you to do, all right, is do the next one on your own. Okay? Do the next one on your own. All right? Thinking about what you need to know. F of -2 equals -2. What's the value of f of 2 when f is the antiderivative of f of x? And I'm going to decrease this image in size so you can see the graph, because the graph is needed to answer this question. Once you are done with this question, you can move on to the worksheet. Have a great day, everybody.